So, good afternoon to everyone. So, I am Mohonapriya Ji. I am Assistant Professor of Department of Aeronautical Engineering. So, I am going to discuss about the properties of fluid and what are the properties which is in the fluid. So, we are going to see that. So, first of all, what are the topics we are going to cover today is, first one is introduction to fluid mechanics. So, we are going to see what is mechanics and what is fluid. So, why we are going to study this unit, that is properties, and second one is what is a fluid. So, why we are calling as fluid. So, we can tell that as liquid, we can tell that as gas. So, why we are calling that as a fluid. So, what is the purpose and what are the types in that fluid. So, based upon the engineering application, it also classifies and also generally based upon the physics, that is generally we are also classifying the fluid into different categories. So, we are going to see that, and next one is what are the units and dimension and what is the purpose of unit and dimension in the fluid mechanics, and next we are going to the main topic is fluid properties. So, there are a lot of properties in that. So, the main property of that fluid in fluid mechanics is viscosity. So, what will happens when the temperature changes, whether the viscosity will changes or not. So, that we are going to see. So, next thing is, so now we are going to enter into the main topic, that is what is mechanics. So, the study of behavior of the fluid, that is we are going to study the behavior of the fluid. So, when it is in a static position as well as in the motion, that is by using the forces we are moving the object. So, what will be the behavior of that fluid when the body moves. So, that is that we are calling as the mechanics. And the mechanics, in mechanics it is classified into two things, one is statistics and another one is dynamics. So, what is statistics? The study of the body at a rest position, that we are calling as the statistics, and next thing is dynamics at in a motion, that is when by using the forces we are moving the object. So, that they deals with we are calling as the dynamics. So, it is classified into many types, fluid kinematics, fluid dynamics. So, there are a lot of types in this. So, next one is what is fluid. So, fluid we are telling that fluid is nothing but a liquid or gas. So, why we are calling that fluid as a liquid or gas. So, why we are calling fluid. So, if a substance which have the capability to flow, that substance we are calling as the fluid. So, if a liquid have the capability to flow as well as gas has the capability to flow. So, we are calling liquid and gas as a fluid, but the solid does not have the capability to flow. So, that why it does not come under the category of fluid. So, only liquid and gas we are calling as the fluid. So, what are the based upon our engineering applications, what are the fluid means? We are considering water, oil and gas. So, these three we are considering as the engineering applications. So, based upon the engineering applications, what are the types of fluid. So, we are categorized as one is ideal fluid and another one is real fluid. So, how we are classifying this ideal as real? So, based upon that, so I have already told that viscosity is the main property. So, based upon that viscosity the fluids are classified. So, one is ideal fluid and another one is real fluid. What is ideal fluid means? It is nothing at, so the fluid that does not possess viscosity. So, it does not have viscosity. So, that type of fluid we are calling as the ideal fluid. So, ideal fluid means without viscosity there is no fluid. So, so why we are calling this? So, for experiment, for explaining a theory, so for explaining a theorem, so for that purposes we are considering a fluid. So, that fluid we are calling as the ideal fluid. So, generally we are calling this ideal fluid as imaginary fluid. So, next one is real fluid. So, that is nothing but it possesses viscosity, it also incompressible. So, if a liquid possesses viscosity, so that type of fluid we are calling as real fluid. If a liquid does not possess viscosity, that type of fluid we are calling as ideal fluid. So, ideal fluid is nothing but it is an imaginary fluid. So, generally we are classifying the fluid into two types, one is liquid and another one is gas. So, next, what is the purpose of units and dimension in fluid mechanics? So, unit is the one which have the, so it gives the meaning of a value. So, for example, so we are what is the viscosity of a liquid? We are telling that 10, we are denoting that as a number. So, if we are giving answer as 10, so that denotes only the number, so that does not denotes the viscosity, that is it does not have any meaning. So, for that purposes we are using a notations that we are calling as the units. What is dimension? So, dimension is nothing but a mass, length and time. That is, these are the three fundamental dimensions. Without these three we cannot indicate the unit and dimension of a component. So the important thing is we need unit and dimension for notifying a component. And next one is, so these are the fundamental dimensions, that is length, mass, time, force. So by using this only we are denoting the dimensions. So next. So next thing is, so this is the main topic, properties of the fluid. So what are the basic properties of a fluid is, first one is mass density, and second one is specific volume, and third one is weight density, and fourth one is specific gravity. So based upon these four properties we are indicating the properties of the fluid. First one is mass density. Mass density is nothing but it is a ratio of mass by volume. So what we know that the unit of mass is kilogram and the unit of volume is meter cube. So the unit of mass density is kilogram per meter cube, and the second one is specific volume. So it is nothing but it is a reciprocal of the mass density. So we know that mass density is equal to mass by volume. If it is being a reciprocal of mass density, what a specific volume is? So volume by mass, so the unit is meter cube per kilogram. And next, third property is specific weight. So specific weight, it is also called as a weight density, that is weight by volume. So we know that mass is equal to weight by acceleration. So this is a general thing which is used in the physics. So weight is equal to mass is equal to weight by acceleration. So we can write the weight as mass into acceleration. So therefore weight density is equal to mass into acceleration due to gravity divided by volume. So we already know that mass by volume is nothing but the mass density into acceleration due to gravity. It is denoted by g. It is common for all the thing. That is a constant value. So therefore weight density is equal to mass density into acceleration due to gravity. That is W is equal to rho into g. So this is the thing. So next, what is the unit of this? Newton per meter. Next one is next property is specific gravity. So it is nothing but it is a ratio of weight density of the given fluid to the weight density of the standard fluid. So here we denoting the standard fluid. For liquid it is a water, and for gas it is air. So we are considering the standard fluid for liquid as water, and we are considering the standard for fluid standard for gas as air. So what is the given fluid means what? So for specific gravity what they are asking, so that we are going to consider that fluid as a given fluid. So therefore weight density of the given fluid by weight density of the standard fluid. So standard fluid for liquid is water, already I told it, and standard fluid gases air. So what is the weight density is equal to rho into g. That is the formula for weight density. So if it is be rho into g for a given liquid divided by rho into g for a standard fluid. So the density for the given fluid and the density for the standard fluid is different, but the acceleration due to gravity is a constant value, that is 9.81. so that will be cancelled. So the final definition for specific gravity is density of the given liquid to the density of the standard fluid. So therefore W is equal to rho by rho. So it doesn't have any unit, that is kilogram per meter cube divided by kilogram per meter cube, it will be cancelled. So the unit for specific gravity is that does not have any unit. So next thing is Newton's. Before entering into the property viscosity, so we have to know a law that we are calling as Newton's law of viscosity. So it is nothing but it depends upon the shear stress, that is deformation occurs due to shear stress. So that is we are calling as a fluid. So here Newton's law of viscosity, so that is shear stress, that is tau is directly proportional to the rate of shear strain or velocity gradient. So the rate of shear strain is nothing but du by dy. Here du is nothing but the change in velocity and dy is nothing but change in distance. Therefore tau is directly proportional, that is shear stress is directly proportional to du by dy velocity gradient. So for removing that constant proportionality, so we are introducing a component we are calling that is viscosity. Therefore tau is equal to mu into du by dy. So this is the formula for viscosity. So next thing is based upon this law, so we are categorizing the fluid into two types. One is Newtonian fluid and another one is non-Newtonian fluid. So Newtonian fluid is nothing but it obeys the Newton's law of viscosity. Non-Newtonian does not obey the Newton law of viscosity. So these are the two types of liquid that based upon this law. So next thing is the important property is viscosity. So it is the main property of the fluid. So when one layer is moves over the another layer, so molecule interaction will be happened over them. So due to this molecule interaction, some internal resistance will be occurred. So that we are calling as the viscosity. So this is the main thing. So without viscosity, any liquid cannot be defined as a fluid. So viscosity is the main property. So again I introduce, so when one layer of a liquid moves over another layer of a liquid, some molecular interaction will be happen. Due to this molecular interaction, so internal resistance will be occur, so that we are calling as the viscosity. So what is the unit of viscosity? So tau is equal to mu into du, mu into du by dy, so therefore mu is equal to tau divided by du by dy. So this we are calling as the viscosity. So viscosity, this viscosity is also called as dynamic viscosity. And next thing, so we know that when the temperature change, whether there is a change in viscosity or not. So if the temperature changes in the fluid, so that the viscosity will affect or not. So that is the thing. So whether the temperature affects viscosity, yes, the temperature affects. So when the temperature changes, the viscosity also changes. So for a liquid, we can, for example, we can take for a liquid, so when the temperature increases, viscosity will decreases. That is, so for example, we take water in a bowl, so we are going to heat the water, so it becomes vapor, it starts to becomes vapor. So the molecular interaction will be low, so there is no internal resistance, so therefore viscosity will decreases. So this is the happened in a liquid. For a gas, so when the temperature increases, viscosity also increases, so there is no formation of vapor, so viscosity also increases. So this is the thing. So when the temperature affects the viscosity or not, so definitely when the temperature change, viscosity also changes. So this is the numerical problem. So based upon this topic, so this is the thing. So already I have introduced the I explained the properties, that is, calculate the specific weight, density and specific gravity of 1 liter of a liquid which weighs 7 Newton. So that is here they have given the volume and the weight. So based upon the volume and the weight, we can find the value for weight density. So we know that weight density is equal to rho into g. We know the here weight and volume will be given. So another formula for weight density is weight by volume. So here the weight is given 7 Newton and the volume is 1 liter of liquid. So convert this 1 liter of liquid into a in the terms of meter cube, that is 1 liter is equal to, we know that 1 liter is equal to 1 by 1000 meter cube. So by using this, we can find the value of weight density. So when we find the value of weight density, by using this we can find the value of specific gravity. So we know that specific gravity is equal to weight density of the given liquid by weight density of the standard liquid. So we have find the weight density of the liquid and the weight density of the standard liquid. So the constant value for density of fluid is 1000 kilogram per meter cube. So by using this value, we can find the value of specific gravity. So by using that specific gravity, we will find the value for density. So by using this, we can calculate this. So this is the assignment for your today classes. Thank you.